let's take a look at our next experiment. Okay, today we're going to be talking about measurement and uncertainty. Whenever we do an experiment and we use any of our equipment in the lab, there's always going to be some uncertainty that's involved with our measurements. Okay, there's two important things when we take measurements. There's precision and there's accuracy. Okay, now, let's say I have a set of bullseyes. Okay, so I'm going to draw 3 bullseyes. So there's bullseye number 1, okay? There's bullseye number 2, and there's bullseye number 3, okay? Let's say we're playing darts, okay? If we're playing darts and we have a bullseye that we're throwing at, we want to get right there in the center of that bullseye. Okay, so that is our target value. Okay, if we can get the center of the bullseye, then we're accurate. So, all right, let's try our first shot. We're going to throw 3 darts because anytime we do measurements, we do things at least 3 times so that we can average things out properly. So, I'm going to throw a dart here. That didn't even hit the bullseye. I'm going to throw a dart here. Well, that one at least hit the target. I'm going to throw a dart here. That one also didn't even hit the target. Okay, this is what happens when I play darts because I have terrible aim. I am really good at embedding them in the wall. Okay, now let's have somebody else throw darts. Okay, this person threw a dart here, threw a dart here, and threw a dart here. They did much better than me. Okay, they at least hit the target each of the 3 times. Now let's have our third person. 1, 2, 3. Oh, that person did really good. Okay, all 3 of theirs were clustered in the bullseye. So let's take a look. Let's analyze this here. If the center of our target is our bullseye, okay, that's our accurate spot. Did we hit that center of the bullseye? No, I didn't hit the center of the bullseye, so this is not accurate. Okay, that is not accurate. Now, all 3 of my dart shots went in completely wildly different places, okay? So not only did I have a hard time hitting the target itself, I had a hard time repeating and replicating what I did each time. So this is also not precise. Okay, so not accurate, not precise. All right, let's look at our next one. Okay. So all 3 of those hits were all clustered around together. So they did not too bad clustering, but did we hit the bullseye? No, that person didn't hit the bullseye. So this person was also not accurate. Okay, but this person grouped all of their shots together. Okay, they were able to repeat what they did over and over again. So this person was precise. Okay, so not accurate, not precise, not accurate, but actually precise. And then let's look at our third person. Okay, our third person hit the target. Okay, so our target is what we want to hit. So this was accurate. And all 3 shots, again, were clustered together. So this is also precise. Okay. So what you're going to be doing with this experiment is you're going to be analyzing your beaker, your 50 ml graduated cylinder, and your 10 ml graduated cylinder, and assessing whether or not you have good values from those. You'll also be doing the same with your balance. Okay, so we want to make sure that we have all of our equipment. Okay, so we're going to turn to page 6 where we have our equipment list. Okay, our equipment list tells us to have our scale, our 10 ml and 50 ml graduated cylinders, our 25 ml Erlenmeyer flask, our 250 ml beaker, 2 plastic cups, 1, 2, our thermometer, and a permanent marker. So I have a Sharpie here. Your grease pencil should also work. In fact, the grease pencil is easier to get off than the Sharpie is. So I would probably use your grease pencil. Okay. All right, the other thing I want to make sure I have are my data tables. And remember, when we record our data, we have to record in ink. Okay, so let me go ahead and erase my board so we can use it again. Okay, so the board's erased. All right, I have my equipment gathered. The other thing is that you'll be taking the temperature of water because you're going to need the density of water. So I would also recommend before you actually start the experiment to get your tap water ready to go, get it out of your tap and let it sit out for a little while. In fact, it would probably be a very good idea if you pause this video right now, went and got a container, got your tap water, and then let it sit out while you finish watching the intro video before you actually do the experiment. So that would be my recommendation. Okay, so I've got my tap water, I have all my equipment, okay? Does anybody know what I am missing before I do my experiment? If you said PPE, you're correct. So let's put the PPE on, okay? All right, so I've got my lab coat. Let's put that on. Okay, we want to make sure that it is fastened. Okay, so mine has snaps. Yours has buttons, that's fine. Okay, so I'm going to snap my coat. Again, this is my nice big coat left over from pregnancy. Okay, I'm going to get a pair of gloves out. So 1 glove, 2 gloves. And I'm going to put on my safety goggles. Okay, so safety goggles. Okay, put my gloves on. Make sure that I don't have a gap with my skin. So I'll put the cuff back over my glove. All right. Okay, so now I have my PPE on. I'm ready to do my experiment. So the first thing we're going to do is uncertainty with our balance. So we're going to turn our balance on. Now, when you turn it on, you want to make sure that it reads 0.00. If it does not read 0.00, on the right-hand side, there is a button that is marked tare. If you tap the tare button, that should set it back to 0. Okay? So we want to label our cups 1 and 2. So I'm going to take my trace pencil. I'm going to label you 1. I'm going to label you 2. It's important that you label them before you measure them. Okay. All right. And then now we're going to put our plastic cups on our balance and record our table. So here is the first plastic cup. So I'm going to get my mass in grams, and I'm going to take my ink pen and write down my mass, okay? I'm going to take it off. I'm going to make sure that it goes back to 0, and then I'm going to do it again. So I'm going to do this 5 times. So I mentioned earlier that we have a minimum of 3 trials in order to get a good statistical average. Well, the more trials we do, the better the number. So if you can do more than 3 trials, even better. So we're going to have you do 5 trials. So you're going to do your mass with your cup number 1 5 times. Then you're going to do your mass with cup number 2 5 times. And then you're going to get an average. So remember, to get an average, okay, we're going to do trial 1 plus trial 2 plus trial 3 plus trial 4 plus trial 5 divided by our total number of trials. Okay, and so we had 5 trials, so we'll divide by 5, and that will give us our average mass. Okay, and then from there we'll be able to calculate our deviation from our average. So let's say our average was 10. And cup number 1 had a mass of 9.94. Well, my deviation from the average would be 0.06 because 9.94 is 0.06 away from 10. Okay, so that is our first activity, is to do the masses of those cups. Okay, all right. Let's get data table number 2. Now, in your lab protocol on page 7, it has table 1. It says glassware and volume of water. So we're going to be testing how good the volumes we get out of our various pieces of glassware are by putting 7 mils in our 10 mil graduated cylinder, 24 in our 50 mil, 17 in the Erlenmeyer flask, and 35 in our 250 mil beaker. Okay, now, how are we going to do this? Well, we have a balance. So our balance is going to tell us exactly what the mass of our water is. Okay, so on my data table, I have a spot for massive empty glassware. So I'm going to start with my 10 ml graduated cylinder. So I'm going to make sure that my balance is on. Okay, and I'm going to put my graduated cylinder on there. Now my graduated cylinder, once it's stabilized, weighed 11.07 grams. Okay, and I want to make sure I have my units on there. Now it's going to say estimated volume of water. So I'm going to take my water. Now this container is a little bit difficult to pour from. So I'm actually, at least into the small graduated cylinder. So I'm actually going to go ahead and use either my beaker or some other piece of, equipment I have around my kitchen to help me pour a little bit. Or maybe I'll just use one of my plastic cups. Okay, so I'm going to pour a little bit of water in my plastic cup. So now remember, we want to read our meniscus. So when we read a meniscus, we want to be at eye level. Okay, so that's why I kneel down. So let me do a quick little diagram here. Okay, so here's my graduated cylinder. Okay, in my graduated cylinder, I'm going to exaggerate this a bit for my diagram. But there I have my meniscus. Okay, the meniscus is this little curved spot because the water is attracted to the sides of our container. So it travels up a little bit. So it's not completely flat. So when I read, I want to read the bottom of my meniscus. So this is my eye. Okay, I want to get eye level to the bottom of that meniscus. Right, so now I'm going to squat down here and I've got my graduated cylinder and I'm going to put my water in there. Now, I poured too much. Well, what do I do if I pour too much? Oh, well, this is one of the advantages of having it in a little container. I'm just going to pour it out. Okay. Now, it's okay if you don't have exactly 7.00 mils of water. We just want you to have about 7. So I'm going to look at mine. And remember, we can read in between. So I've got major marks at every 1 milliliter and minor marks at every 0.2 milliliters. And it actually looks like I got right on a line for 7.4 milliliters. Okay, so my estimated volume of water is going to be 7.40 milliliters. Okay, so now I'm going to put my graduated cylinder on my balance, and these balances go into standby really quickly, so you may have to turn it back on. Put my graduated cylinder on there, and now I'm going to put my massive glassware with water is 18.39 grams. Okay, and then we've got some volume intervals and some uncertainties that we'll be calculating it when we're done. Okay, first thing I can do is a volume of water or mass of water though. So I have my 18.39 grams of my glassware plus water. Okay, so let me erase this stuff. All right, so glassware. So my glassware plus my water minus my empty glassware will give me my mass of my water. So for mine, it'll be 18.39 grams minus my 11.07 grams. Okay, and so if I do that subtraction, I will get 7.32 grams. Okay. Now, why did we say estimated volume of water? Well, again, it's estimated because that's what we think we put in there. Now, we do have some uncertainty again in all of this, okay? So when I looked at that, I had to eyeball. I knew from looking at the markings that I was at least 7.4. Well, maybe I was a little bit off. Maybe I was actually 7.39, but I was eyeballing it right on the line. Or maybe I was actually 17 or 7.41. That last digit is uncertain, okay? Because I had to estimate it with my eye. So we can actually, from our other data and from the density of water, okay, we can figure out how much water we actually had in there. So now this is where our thermometer comes into play. Okay, so let's say I've done all of my water measurements for each of my pieces of glassware. Now I'm going to take my thermometer and I'm going to put it in my water, and I'm going to see exactly what my temperature of water is. Okay, now our density table that we have is in whole numbers. It's 18, 19, 20. So round to the nearest whole number for your temperature of water. Okay, so on my data table 3, I have a spot for mass of water and activity 2. So for my 10 ml graduated cylinder, that was 7.32 grams. Okay, and then my current temperature of water out here in my garage, it looks like my water is 19 degrees. Okay, so, all right, and you'll notice on the data table that the temperature of water and the density of water only has one spot to write it down. It's grayed out in the other 3 boxes because you're using the same temperature and the same density for all 4 pieces of glassware because you're using the same water. All right, so I'm going to look at my table, okay? And oh, okay, my table actually does do the 0.1, 0.2. Sorry, wasn't looking at the table. So what I can do is, as I look here, I've got whole numbers down here, and I've got my decimal points off to the side. So let's say, let me get a better reading then. Okay. This looks like, I'm going to say, actually instead of 19, I'm going to say 18.9 is my temperature of water. Okay, so I made a mistake. What do? Oh, I put a single line through it and I rewrite it next to it. So it's okay if you make a mistake in the lab. It's okay if you look at something wrong the first time and go, oh, wait a second, I didn't look at that right. I need to fix it. We all make mistakes. That's part of being human. So all I do, again, so what I had done is I had written down my 19. Let me erase this. Okay, I had written down that 19. Well, once I figured out that my table actually gave me decimal points, and I looked at my temperature again, and I decided it was actually 18.9, all I did was I put a line through it and went next to it, okay? So it's okay if you make those mistakes. Having a perfect, lab notebook is not the important thing. Taking your data correctly is. So that's what you do when you make a mistake. Okay, now I'm going to use that table, and I'm going to go, okay, 18, and I'm going to go over to the 0.1, okay? So my 18.1, my density of water is 0.9986 grams per milliliter. Okay, so I wrote that down. Now, using the mass of my water and the density of my water at that temperature, I can figure out the volume that I put into that graduated cylinder. So I'm going to take that 7.32 grams. Okay, and then I'm going to have 1 milliliter over the 0.9986. Okay, my grams and my grams are going to cancel out. And when I'm done, I will be left with some sort of milliliters of water. And I'll be able to compare that to the milliliters that I wrote down and see how well my glassware actually delivered that amount of water. Okay, so again, this whole exercise is all about understanding the uncertainty in our measurements and how our different pieces of equipment relate to how good the numbers that we get are. Okay. The other important thing as we're doing our experiments, if you notice at the bottom of each data table, we have space for observations. So as you're doing your experiment, write your observations down. So one observation that I could have written down when I was doing the water into my graduated cylinder was poured too much water, had to pour some out of 10 ml grad cylinder. Okay, so that's an observation that I can write down. And so later on, when I'm going back to working up my data and I'm answering, questions about analyzing my data, I can look at those observations and help myself remember, what did I do during my experiment? And how do I analyze my data based on both my numbers and what happened during my experiment? All right, so once you're all done, you can go ahead and clean up, put everything away, take off your PPE, and then start working your numbers. It's important, I think, at least, because in the lab, if we're meeting face-to-face and we're in the classroom, we only have a set amount of time to do the experiment. So I always tell students, get all your numbers first, do all your measurement first, and then do your calculations. So get all those raw numbers first. Take all your masses before you calculate your average and your deviations. Get all your volumes and your masses before you then start calculating, well, what mass of water was there? So get that mass of your empty container, get the mass of the container plus the water, get the temperature of the water, get all that data first. And then when you're all done, then go back and do your calculations. Okay? When you do calculations, those can be done underneath the data tables in pencil, right? And then when you write numbers back in the data table, make sure that is done in ink. Okay, so I know this isn't the most exciting experiment we have this semester, but it is a very important one because it is critical that we understand the limitations of the equipment that we're using. All right, so that is my explanation for our measurement and uncertainty lab. So hopefully you'll learn some valuable stuff from this. And if you get stuck or you have any questions, as usual, shoot me an email, message me on campus, come to my office hours, and I will see what I can do to get you unconfused and understanding what's going on with our various laboratory equipment.